of applause for this amazing work.
Just trying to build the anticipation. All right. So thank you for coming to the talk. My name is Devendorf, and this is work that I completed with my advisor at the UC Berkeley School of Information called Being the Machine, Reconfiguring Agency and Control in Hybrid Fabrication. So can everyone hear me all right? I know this microphone's a little strange. Good? Good. All right, so I'll start with the basics. This is a 3D printer. I think we're all fairly well aware of that. Our paper is really exploring how 3D printing technology might function differently if we reimagined how and where fabrication took place. So we were specifically interested in looking beyond the Fab Lab, asking how fabrication might function in making practices that value reflection and close sensory engagements with materials, space, and even other makers. So we see the Fab Lab model of fabrication as one that aims to determine forms, to create precisely what the maker expects. With our design, we sought to support indeterminate, open-ended, unpredictable making practices, where not getting what you expect is not so much a problem, but a resource to open new material encounters, as well as new creative spaces. So, by analogy, there's two ways to go about making bread. On the left, you'll see a bread maker, which is great if you want a predictably good loaf of bread with minimal effort. On the right, you might alternately choose to make bread by hand to experiment with the variations on the recipe. And while this process is more prone to failure, you have the benefit of getting surprised, as well as developing personal strategies or deviating from the recipe in some way. So basically, we wanted to ask with this work what role digital fabrication systems can play within these indeterminate, open-ended practices. So what does a CNC manufacturing system offer beyond automation? So we began by reimagining the workflow of making. So the existing workflow is largely unidirectional. The maker selects materials and a model, and the machine produces the physical version of that model. By contrast, we imagined a system where multiple factors had the opportunity to affect the emerging form. The maker might come to the interaction with an idea in mind, but what ultimately emerges through rich engagements with materials and context and the machines and the data and their own intentions. So all of these actors may or may not be willing to do what the maker wants, but in that moment, something kind of new and unexpected is able to emerge. So similarly, by reconceptualizing the workflow of making, we're also rethinking the space in which fabrication takes place. In the existing model, the machine and the maker don't necessarily need to occupy the same space, and for that reason, making can become invisibilized. In our vision, we co-located the maker, machine, and the materials in some particular space, and we felt that that was critical to both increase the visibility, oh, that was surprising, the visibility of making, and foster a close reflective engagement between all of the actors involved. So anthropologist Tim Eingold calls this relationship with materials correspondence. So to Eingold, making isn't about realizing an existing idea so much as it's about sort of having this negotiation with all these different materials and factors. So these kinds of cooperative and reciprocal engagements with fabrication systems have been studied, largely under the banner of hybrid craft. So work by Mueller and Rivers explores how human and machine cooperation can lead to new opportunities and even suggest how this offers increased precision. Work by Willis and Zorin allow for a broader set of factors to influence the form produced and model interaction after practices like sketching or sculpting. So in this design, we conceptualize making as art making as opposed to crafting or sketching. Calling it art making allowed us to place an increased focus on the symbolism of using particular materials in particular ways. So for instance, each entity involved in making can communicate a particular meaning in relationship to the other materials that are being involved in making. The materials here aren't just stuff, like the physical stuff. It's the digital files, the other people in the space, the weather, you name it. If it affects the form, it's a material. So we wanted to sort of explore how this link between the physical work of making can be paired with the conceptual work of making, And we wanted to ask, how can our design support makers in crafting these meanings along with materials? So now I'm going to present our project, which we called Being the Machine. So Being the Machine is a system that we built to support these kind of engagements we've described. And it actually does so by flipping the expected roles of humans and machines in making. So it basically asks the human maker to literally perform the exact same instructions typically given to a 3D printer. So I'll tell you how this works a little bit more. So it starts in a fairly typical way. You upload a digital model you find online. And we use an open source G-code generator to create a G-code file from that model. So G-code, for those who don't know, is the language that 3D printers and other CNC manufacturing machines speak. So it's basically an ordered list of instructions, which you see over there, that tells the machine exactly where to go and how much material to kind of spit out along the way. So I'm going to present you with a very honest demo video. This is not our best case. This is my first time trying this system. Well, I've used the system, but first time with this particular material. And I wanted to give you a sense of what it's really like to use something like this. So, oh no, I have spinning beach ball. Okay. I can describe in great detail what the video would be showing. Oh, this is problematic. It appears as though my computer has completely frozen. So I'll go on to explain in the hopes that the spinning beach ball. Yeah, I'm giving a talk about surprise, and I get this, so it's sort of, I deserve it. So basically what I'm going to do is I'm going to start preparing the materials, which is pancake batter in this case. And I'm going to, okay, I really need to get this to work. Sorry. Should we? Okay. My computer is not dead. It's just decided it doesn't want to respond.
Okay, we are just going to restart the presentation tool, but the computer is still alive. Take your time.
Okay. That's my daughter. You can just enjoy this while Keynote bounces up and down. No bother. Just so you know, we did test this before. I have it on a USB stick if there's another computer that might be.
Yeah, so we are going to fix this. We are using a different computer now. From the USB stick. It's going to be the next. Okay, let's connect it. Do you want to connect it? Yes.
Thank you.
Yeah, give it a minute. So if you want to be involved in the process, we just copy it to my machine now, and then we're just going to open it, and we hope some magic happens. not going to. It's going to be good.
Yeah, it's just, that's annoying.
So it's less than a minute.
It's here. It's getting closer. 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 Come on. I know. I deserve that. Okay. Let's go back. Okay. So going back to where I was, I apologize for that. I'm sorry to make everyone wait. Here's the demo video, much anticipated. So I'm preparing the materials in this cake pancake batter. I'm measuring the sort of building environment and how high the laser pointer is positioned. And I'm using that to sort of transform the G-code just to the instructions that the Arduino can read. And those are the sort of translated G-code file. So here what I'm doing is I'm following the laser point with my materials. I have a clicker there that allows me to play the laser point forward or backward, and also forward one instruction or backward one instruction. So follow, follow, follow. And this is the actual pan-tilt mechanism that I'm using to control the laser pointer. So you fill in the layer, and in this case I'm actually stacking the layers, but there's also a setting in the system so you can just build in place. So there's a lot of unpredictable encounters in this. One is that your extruder could clog and explode. You know, it was exciting. Your daughter can try to grab your key fob. Or you can maybe not know how to load the extruder properly and spill it all over the place. In the end, you end up with something more or less like your digital model. Okay. So anyway, yes, before and after. So this is why I'm calling it an honest demo video. It's not, I don't think it sort of satisfies various standards of beauty, but I do think that there's something interesting that the system's not magical. It does take work, and it's about sort of working with these materials, including the system, to kind of develop these skills. So I've worked now for about a year with the system with different materials and shapes. So my very first construction was a hand made of pipe cleaners. I then made a vase that dies with the flowers. I made a gun, very topical, from Good and Plenty candies. I made some more unsuccessful models out of Cheese Whiz and various torus knots out of gumdrops. And then I did various form studies, specifically with the Stanford Bunny, which is the test bench model for most 3D printers. First was with jelly beans. It was a little bit too coarse, and I found that BB gun BBs give you a very nice resolution when you're making the Stanford Bunny. So at TEI this year, I actually attempted to make a 5-foot Stanford Bunny out of balloons, where I realized that this was a very stupid idea, and balloons like to be in the wind. They don't like to be tied into giant rabbits. So in my own practice as an artist, I've really taken to drawing with the system. My background's in 2D drawing, and I've spent a lot of time sort of following the toolpaths and working with it and exhibiting this at various shows. So I'm not the only person who've used this. We invited, I'm just going to skip through since we're running late. We invited 14 people to use the system, aged 22 to 43, and they identified as makers, artists, crafters, tinkerers, and they had mixed experience with 3D printing. We let them choose their own model and materials for building, and we interviewed them while they were building and after, and we used a grounded theory approach to kind of identify themes coming from these interactions. So people made models out of all kinds of things. There was plastic bags, corks, leaves, slide films, and even food. And each session took roughly about 90 minutes. So following this single laser point, it's difficult to communicate in the video how kind of emotionally intense this is, because you have no information about where it's going. You just kind of have to trust it. And for some of the participants, they were kind of unable to even talk while using the system. And while some people found this really meditative and rewarding, other people found it completely frustrating. So this kind of led us to look at these different approaches, and we identified 4 different roles that people kind of wanted the machine to play within their making practices. So those roles are as follows. The first was Omniscient Helper. So people who wanted the machine to play an Omniscient Helper role felt that our system should have more knowledge of their building materials, and it should have showed them the, quote, right way to do something to get the exact model out. So both of the participants in this category had extensive experience with 3D printers, and they also enjoyed craft hobbies like knitting and painting. So they let the machine dictate exactly what they would do, following it really precisely, till the machine told them to do something they thought was wrong, at which point they just gave up and ad-libbed. The second category was people who saw the machine as a symbol of perfection. So they used the system to kind of practice doing something imperfectly with what they felt was a perfect system. So one described herself as a, quote, recovering overachiever, and felt that she needed to cultivate acceptance of her personal imperfections in order to increase her personal creativity. So being the machine allowed both of these participants to kind of wrestle with this becoming comfortable, the idea of not doing something the right way. So I'm going to talk about these last two categories in more detail because I think they offer the most insight into future directions. So the first was a collaborator with unique talents. So these makers identified as crafters and hobbyists and had mixed experience with 3D printing. They didn't follow the laser point too cautiously. They sort of played it forward a bit, and then they would just sort of estimate the path of their materials. Claire used ivy that she had cleaned from her backyard to make a goat's head. She followed the points with ivy, making it very clear decision not to cut the ivy in an effort to sort of preserve its natural shape, even though this made things a lot more difficult for her since she had to hold it in multiple spots. And she summarized the attitude of this entire group nicely when she said, I like that the machine is the expert on the abstract shape, and I'm the expert on the material. The machine is only making the suggestion, and I'm the one realizing it. So Nina was another participant in this category, and she made glasses out of magnolia leaves. She liked the idea of making something wearable, and when we did a short walk to find materials, she noticed the interesting texture of the leaves and the fact that they took on a suede-like texture when they died, something she thought would be interesting to explore as they aged. She, like Claire, liked the idea of letting the materials determine the shape. She cut the leaves along their veins to maintain its poetry, and while she conformed to kind of the paths of the printer. She even did something clever by using the strong spine of the leaf to add structural integrity to the arms of the glasses. So like Nina, most participants in this category enjoyed the opportunity to interpret the machine instructions and were happy to ad-lib as necessary to create an object that they thought would be interesting. So the final category is generative constraint. So it's interesting that each participant within this category had a background in the fine arts. So they either had an MFA or they were actively exhibiting in art shows around the world. So most of these participants came to the study with a set of materials that they'd been working with for a long time. They didn't expect perfection, but they were more interested to see if this constraining process, building like a machine, might generate new ideas, hence the category name Generative Constraint. So Helen, who you're seeing here, was an illustrator and a photographer, and she worked with transparent plastics. So she brought a number of plastic bags to the study and wanted to use them to recreate a physical version of a to-go cup, something very disposable. So she even diligently followed the laser, even when it was just making concentric circles, and she could have reasonably done it by hand. And she did this because she said she was interested in using her own labor, that it would allow somebody to see the object she's making and experience it as a translation by a person. So for Helen, the act of following the laser and doing the work of the machine was symbolic and something she wanted to be visible in the resulting form. Her making wasn't just a means to an end, it was an end in itself. So finally, Josh is a composer, and after explaining the system and how G-code worked, he kind of made this link between scores and G-code, that G-code is sort of a score for an object, while he's typically making scores for music. So with this in mind, he followed the laser point and placed a musical note at every place that the laser stopped, creating a score for a string trio. And he began to learn more about the specifics of G-code and how these might map to music in more or less interesting ways. So he described how the concept of layers mapped well to sound and how different shapes could sort of lend interesting sonic compositional properties. So reflecting on this research and what we found, we think that digital fabrication processes can play a really unique role in indeterminate practices, whether it's to cooperatively realize difficult shapes, where cooperation is broadly construed among people, machines, and things, to defamiliarize an existing practice, to make things strange in order to open up a new space and a new way of understanding maybe a familiar set of materials and concepts. And finally, to explore the symbolism of technology and reflect on what it means to use technology in certain ways, and maybe how that highlights certain relationships that aren't otherwise evident. And the design features that we think really supported this were the fact that we opened the process to interpretation, that the human made the final decision how to act on the materials, not the machine. And similarly, that we actively resisted existing human practices. So we didn't do it like sketching or knitting or crochet. We really tried to create something different to sort of allow for this rediscovery and enchantment and strangeness of the activity. So our paper points to a lot of interesting directions for future work. One is exploring these relationships over time. If we're working with machines as collaborators, how personal is that relationship? Does everyone want the same kind of collaborator, or do we need to make these hyper-specific to each maker? Similarly, while we were trying to go for this very cooperative relationship, we found that the digital model played a relatively passive role in this interaction, and I think there's ways to make this more active and interesting. Finally, multiple makers, these can be material as well, and we're sort of imagining how the design of digital fabrication systems can really lead to a socially engaged practice. So we hope to continue to explore fabrication and the ways it can foster reflective, enchanting, and site-specific engagements in various spaces and environments, functioning less as a purely instrumental system and more as a platform for inquiry into the relationship between technology and broader cultural contexts. So thank you, and thanks for being patient.
So yeah, let's just have one or two questions before we all run out to the lunch break.
Daniel Ashbrook from the Rochester Institute of Technology. Very, very well handled the laptop failure.
Thank you.
Something that occurs to me with this is the possibility of teaching as well, to show people how they can work with different materials, to possibly do it socially, to show people how they can cooperate building things, and also to make permanent structures that just would not be creatable by a 3D printer easily.
Yeah.
You could build a log building, for example, using a system like this. I didn't really have a question.
Oh, okay. Yeah, I mean, I'm working with an architect on a different space, and he's interested in doing computational brickwork, because you could feasibly do scale. But what I found is it's like, you don't really have this much materials just laying around, oftentimes. I mean, in terms of learning, I think it's interesting, I didn't focus on it, but from like an embodied cognition perspective, or a syntonic learning perspective, you could see how this might be an interesting way to learn more about 3D printing, maybe before using a CAD tool. So,
Yeah, very cool. Thank you.
thanks.
Hi, thank you for a very inspirational talk. I'm Young from NASA. I have a question that you applied like a stacking metaphor. So have you ever thought about, like, rather than stacking, that like carving? It's like opposite way. Like for example, like carving artists can maybe apply their own artistic senses when they are carving. So maybe it can be output can be more beautiful, I think. So have you ever thought about that?
We definitely have thought about it. It would require a different set of toolpaths, but it's actually possible with the existing system. You would just use the G-code from a milling machine instead of an additive machine. But we did have some user study participants come with a Dremel, and they were actually interested in doing like a subtractive additive thing, so creating a mold. But that ended up being a little too messy for the workspace I had organized. But yeah, thank you. Cool. Thanks.
So let's thank Laura again, and that's also the end of